Hi, hello everyone. So in last video we did our first person shooter camera, right? And in this video what I want to do is actually kind of skybox for this. So the idea of a skybox is wherever you turn, right? You want to see some environment. So if you never did skybox, it's very easy to do. It's not that hard. We're just going to need new render pipeline, some geometry. But first of all, we're going to need skybox textures, right? And just to explain Skybox a bit further and how the textures work. So basically for Skybox, you just make it up of 6 textures, right? And it's sort of like you're inside of cube, right? And then you have up, left, back, front, right, and down textures, and you're in the middle of the cube. And whenever you look around, right, you will see some sort of data. And this is for my Android, no worries. And for the textures, what we're going to use, I found this one. It's really nice, so you can use it. I'm going to leave description. Sorry, I'm going to leave link in the description of the video. Shout out to Jokum, who is author. So I just wanted to give credits here because I'm using it. And then the second part of code that you're going to need, that we're not going to write, is just this method, which is called Skybox geometry. So you can just copy it, right, and then you can paste it inside of geometry builder. I already did it. The point is, these are just basically the vertices of a cube, so it's nothing spectacular. Just copy it, paste it, and then the vertex count as well. We're going to need it later on. And yeah, that's about it. And then with that we can actually get started. So just to quickly explain trick to that, right? If you just render cube, and you can apply to that, oh, this is really cool cube. Anyway, you can apply some textures to that cube. But the point is, if we move camera outside of the cube, right, here, and then we're just seeing cube and doesn't act like environment. But if you imagine just like here at the origin, if you place camera at the origin and just look at the cube, right, with your mouse, you're moving around, then you're going to see only points on the cube, right? So the trick to it is kind of just to get rid of your eye or your position of a camera, and that's it. So you're just rendering always from the middle point of that cube, which is usually right 0, 0, 0. You're at point 0, 0, 0, you're looking around, and that's your cube. And the second trick is you just have to render it in like infinitely away. So there are multiple ways to do it, and we're going to cover 2. So just one of them is just like don't draw with depth enabled. So it's going to write this. And I'm rambling here. This is way easier than you think. Once we cover it, it's going to be very easy to understand and reason about. So let's get started with it. So first part that we can start it with is, I guess, our shader, because we're going to need different shader for this. And here I'm just going to call it, I think Skybox is perfect name for it, WGSL. Let's get started with shader. So usually, like maybe we can even copy this one, and then we can just get rid of stuff that we won't need. So let's just copy our Skybox. And our vertex input, we only care about the position, right? So you might be asking, how if we have six sides, right? 6 textures for each side of the cube, how do we sample it? Well, we're just going to sample it per position, and it just works beautifully because it's how it's mapped, right? So you're going to see it, but we can get rid of this. We don't need it. For vertex shader output, we don't need this. We need texture coordinates, but location is not 2 anymore. It's 1, right? Because we're changing it. We're going to need perspective view. Should be called projection view. Transform we don't need about because we're always at the center, right? And I'm just going to leave this as is. Of course, we need to be group 0 right now. Then let's see further. I think this is fine. This is fine as well. Fine. Transform we don't have here. So the perspective view, I mentioned that we need to get rid of transform part of the matrix, the part that's actually responsible for eye position, right? And we can do it either here when we paste the perspective view, or we can create another buffer, and I'm going to actually create another buffer for this. So here I'm going to do nothing. We're actually going to get rid of that in our C# code. But let's go further. And what I mean by this, right? So let's imagine this, right? If you remember, now it's in our basically matrix, right? You have something like this. Actually, let's call this scale. Scale. This you can imagine as rotation part of the matrix. I don't want to write it. Then scale, and then you might have something like translate, right? And 1. So here 0, 0, 1. So this translate part depends if it's row major or column major. It's not relevant now, but the whole idea is just get rid of this transform part. We can set it to be essentially 0, 0, 0, 1, and then you got rid of basically your position, right? It's sort of something like this, where we just get rid of translation, and at any point you're always set to 0 position. So we're just going to get rid of that part from our view matrix, and that's going to be fine. As I mentioned, you're probably going to see it later on. For now, it's not important, and I forgot how to clear this. So clear screen, let's clear it. Okay, color we don't need. Texture codes. Now this is important. It's our texture codes are actually going to be our out position, and it's giving some suggestions here, but I'm not going to take them because later on we can explain them and change them a bit. Okay, position we have, texture coordinates we do have. That's good. Let me just see something. It's actually this, right? And then here, now this is important. First of all, group 1, let's just get that out of the way. But texture is not this texture 2D anymore. It's actually texture cube, right? We're loading cube texture. Sampler can remain as it is. Vertex shade the output. Texture sample is still the same. This is still the same, and then we just can get rid of the color because we don't have it anymore. Okay, I think that's it regarding shader. So going further, I'm just going to take a look at GitHub code because I don't want to like write everything from scratch here. But I guess the next part is actually Skybox pipeline. Skybox render pipeline. It can be something like this, and then I'm going to be very lazy here, and we're going to have to be very careful because I'm just copy pasting code, but I think it's easier to do it that way. So I'm just going to take all of it and then I can just rename it, right? So let's do that. So here we're going to say Skybox. Render pipeline we do need. Transform we don't need. Let's get rid of transform. Transform buffer we can get rid of. Transform bind group, get rid of all of this. Camera, we are going to need it. We are going to need this and this, I believe. Texture, we're going to need it for sure. Default texture. So we're going to make it so that we always need a texture. And actually, let's skip pipeline for now, because first of all, we actually need to load that texture in. So here in our texture, I just want to do another one, and I'm going to call this one cube texture. And it's going to be similar to texture 2D. It's almost the same. It's not like you have to create 6 WebGPU textures. You actually create a one, but for the data you paste it 6 images. So we're just going to correct what we need. So here, right? If we take a look at here, so what are we going to need to do? Let me just move this here. So we're going to need up part of the texture, back, left, front, right, down. So we need to load all those sides. So here we're going to need to have left image, then right image, top image, bottom. Come on, ChatGPT or Copilot. Front and back. Data, we're just going to load images here. I don't want to complicate things further. This overload is gone, and here So let's just break this apart. This is the boring part, but we can do it like this, right? And then, so if you're interested in this multi-lining, it's Alt Shift on Linux or Windows. So you can just do Alt Shift and then down, 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 down. And this, and I'm just going to say cube texture here. Once again, let's do this. So, and this selection is Control Shift, right? So this. Select image. The image, and I forgot to rename here to cube texture. And I'm going to zoom in a bit. Apologies, I always forget that. Okay, this is good. It must be unsafe. So let's just make class unsafe. Going further, so this is going to change. We don't need this overload. So it's going to be similar to this image one. But we can create a new method, which is going to be called create cube texture. Texture wheel, I think we're going to need to change that as well, but all other things are fine. We just don't need this create empty texture. I don't want to like cover that. You can do it on your own if you feel like it, but I don't. And size, is it relevant? I guess not. Okay, good. Here it's complaining. Method must have a return type. Okay, I misspelled here, so fix that. Okay. So now we need to go to our utils, texture util, and we need to create that method that's going to load cube texture. I guess it might be similar somehow to this one, but we're probably going to change most of it. So I'm just going to copy paste here and going to call this create cube texture. Texture, if I could type. So as you can guess, we're going to have left image, right image, top, bottom, front, and back image. Okay, that's good. So here, I'm just going to get rid of all of this because we can do it once more to fully explain it. So we're going to start with texture descriptor, right? Because we need texture descriptor to actually create a texture, right? As you can see here. So I'm just going to copy paste this part. We start with the descriptor size. Now this is important, right? First of all, we need to fetch, and I'm going to on assumption that all of our images are of the same size. So you can probably create some validation to make sure that all images are of the same size. I don't want to like complicate these videos, so it's really up to you. But for now, I'm just going to say left image height. And this is important, right? Adapter layers. We have 6 textures, so we just need to place 6 here. Okay, texture dimension. It's still 2D. Format can remain the same. These values are the same, so we don't have map levels or multi-sampling yet. But descriptor, then we have to describe usage. So what do we need to do? We need to use it in shaders. So we need texture binding, right? And we need to copy to it. So this copy destination, right? It just means we can write from our CPU to the GPU. So nothing spectacular here. And then we can create a texture, right? So you just need to paste device and the descriptor and the texture is created. So now we just need to write to it. And I'm going to do it like this. I'm just going to create an array because it's going to be easier. So array of our images. And then in that array, we're just going to paste all of those images. And I think order is important here. So let me see. First right image, then left image, top, bottom, front, back. So if something is not right, when you do this, just try to play with the order of images by the end of it. Then we need to have image copy destination. Is it image copy texture? Right, this will be our destination. So it's saying where we want to copy. We want to copy to our texture, right? Destination, map level we have. That's not relevant for now, so it can be just 0. It's actually relevant, so you need to place 0 here. My bad, origin is just 0, 0, 0, and then the aspect is all. And then we still haven't filled out everything, because we're going to do for loop for this, because we need to change actually origin Z, because right, we have 6 images, so that's going to change. But for now, we're going to do it in for loop. So you're going to see data layout source. What's our source? Our source is going to be our data, but we're not filling it yet because we need to loop to those images. And then I++. So here, what we wanna do is, right, this destination, check this origin. So we actually need to write to it. So origin can be our I. So that's why this order here is important, right? Because first the right image is loaded, then left, top, bottom, front, back, etc. So that's kind of important, and it's not origin, it's origin Z here. So we need to change destination origin here. All right. So source rows per image. What's that going to be? To be honest, since all of our images are of the same size, right, we can actually just set it here. I was thinking of doing it a for loop, but that doesn't make sense, because by default we're always going to use images of the same size, otherwise it doesn't make too much sense, right? So let's just leave it there. Then we're going to need to have extend size, so I'm just going to create extend 3D. Extend, same kind of thing, right? Depth or layers is 1. So now we can fetch our image. And here I'm just saying images I. So let's format this a bit. And I need to get those pixels. How did we do it? Right here. So we can do it with image info, right? So back to here, we can get our image info, right? So this, and then we can fetch our pixels, and then we can just say fixed, right? Because we need pointer to those pixels. The WebGPU API works with pointers. So pixels pointer to our pixels. We read the image into our pixels, right? And then we just need to write to our texture. Okay, not like this. Q write texture and the Q type. Okay, then the second parameter is destination, so we had it, right? So destination says where we want to copy our image, right? And it's right here, we want to copy it in a texture. And then the origin Z is only things that is actually variable here. So all of this is the same, but we just need to vary this. So we could have created 6 destinations, but as you can see, it works like this as well. So that's fine. Then our actual data. And then we need size of the date, right? So I'm just going to move this to a new row. And then we have our source. And then we did extend. Okay, so it's going wild. So just to explain it. So we write to our texture, as usual we write to queue, then we paste destination, our actual data. So here we're multiplying by 4 because we're actually using integer array. If it was byte array, then it would be just length, right? So we need to take that into account, actually size of integer. So you can do it like this as well, right? That's also completely valid. Then we paste source and then we paste extend. And yeah, that should be it, I believe. And then we just need to return our texture. Going back to here. So we need to paste all of these images, and I think which one is first? Let me check because this is going to be important. So wrong class. Let's see, left, right, top, left, right, top, left, right, top, bottom, front, back, I believe. Okay, good. So here it's complaining null reference. So it's never actually going to be null, so we can get rid of that. Now for the texture view, we probably also need some changes. So let's implement those changes. So I also think this is going to be very similar. So I think this might be only change, but let's just copy it for simplicity. So create cube texture. So format, preferred texture format that remains the same, aspect is all, and I believe here this is the only change that we might need here. Array layers, this is not relevant. Let me just check notes as well. Yeah, actually array layer count needs to be 6. All right, creating texture view, and this information I'll just quickly get rid of it. So it's not relevant because we have validation anyway. So all of this is going to be caught if something goes wrong. But these two changes are all that we need. So our dimension is cube, right? Because we're in shader, we're using cube texture, and then the array layer count is 6 as well because we have 6 textures here actually. With that said, I think we're done with cube texture. So just here in Skybox, we're actually going to provide it. And then we're going to do nothing. We're just going to continue here. So our texture, do I need this? Yes, but it's cube texture. Maybe even no. We'll see. Let's leave this as is. Let's just assign it. And let's rename this to cube texture as well. It's not super relevant, but whatever. We can get rid of this here. It's cube texture, right? Okay, maybe it wasn't the best name, but whatever. And actually, let's not use default here. So I would leave that to you if you want to handle it. I'm just not going to. So I'm just going to say it's never nullable. So create resources. We don't need this or this, but I'm going to leave method. Maybe we're going to need it for something. Create bind group layouts. So we don't need this transform bind group layout because we got rid of it, right? We need the camera layout because we use it in our shader, right? If you remember, the two layouts that we need is one is for this perspective view that's in Vertex shader, and the other is for the texture sample. So all of this is fine. I'm just going to say here Skybox. All of this remains the same. It is kind of same. It's just view dimension here, right? It might be dimension cube for our texture, right? Here I reused model binding group layout description. I guess that's not really true. So let's see. Texture binding group layout entries, group layout descriptor. For some reason I did this, but that's wrong. So if you made same mistake somehow, I just advise to fix it. But I think that's it. So this method was our create binding group layouts. If you're stuck somewhere, you can always just refer to GitHub code. Take texture bind group. So here it's also a bit more interesting. But all of this is actually just fine. We just paste cube texture, cube sampler, nothing to change here. So I'm just going to change description to Skybox, render pipeline texture bind group. So this method is create texture bind group, and it's pretty much the same. Create bind groups, we just don't need transform bind group, right? So we can get rid of that. We don't have it anymore. So this is for the camera. So this buffer, we're going to need to change it in future, but for now it can remain as is. We're not doing anything here. So it's just, you're going to see, we need to change it a bit in future. And then we can get rid of this, right? So now in our initialize method, so let's just get rid of these bind group layouts, and please make sure to change this here and here, right? This to 1 bind group layouts, and this count as well to 2, and then bind group layer count is 2 as well. Okay. So here we're going to have a bit of a problem, right? Because in our, if I remember, in our render pipeline, I hard-coded the data about the vertex input, right? So these things. So we cannot use that, and as usual, I'm just going to just make sure to copy whole pipeline method, which is quite huge. We're just going to create another overload. And for that overload, so this is for the second one, we actually just want to paste this data in. So I'm just going to say here vertex attribute, vertex attributes. Can I do it like that? Or better yet, vertex buffer layout. So let's just say vertex buffer layout. So what is this vertex buffer layout? If you remember, it's just describing information about this vertex input here. So it's going to be very simple one. I just want to move all of that out. So here it was called layout. I'm just going to rename it to vertex buffer layout. And you want to copy, it's already a pointer. So that's good. So we just need to copy all of this data about our vertex position, vertex color, stuff like that. So let's just copy it. And this vertex attributes. So vertex buffer layout, and then this attributes. And we're just going to change it in our Skybox render pipeline. We can create it somewhere here. Now for the vertex attributes, we only have one now, and that's our position. So we can get this code about the color, right? And then texture coordinates part. We have our layout, attribute count. Please make sure it's 1 now. And then the array stride is just 3, right? Why? Because we just have 3 positions, X, Y, and Z, and we don't need any other information. And then I believe we can just now paste it in here as layout. Or no, maybe it's third parameter. Which parameter it is? Let me just check real quickly. Aha, so because I pasted it as a pointer. Okay, that's fine. We can just paste it as a pointer here. So we can say this and layout. All right. And just for consistency, I'm going to rename it to Vertex buffer layout. But it kind of says type here, so it's fine. So that covers the render pipeline. We're almost there. So we're going to need to create Vertex buffer. But for this, because the geometry of it is not going to change, right? You're always going to want to paste in the same kind of geometry for this class. I'm just going to copy, sorry, not copy, create Vertex buffer somewhere over here. So let's go here, and we can actually, that's why I wanted to actually have resources, right? Because it is our resource. So if we go to our resources, we're going to say Vertex buffer, this new Vertex buffer. So we need to pass our engine. So we now need the geometry, and that's going to be our geometry builder, right? Create Skybox geometry. So now we have to make use of it. And I think class was, this is interesting. So we have geometry. And then we can just initialize that, and I believe we use this interleaved vertices. Not that they're really interleaved because we just have position here, but who cares, this is fine. So we have that vertex buffer. That means we're probably going to need to dispose it. Actually, I can reuse this here. So we don't have here transform or this. Although I'm missing camera, so I'm probably missing dispose for the camera and only train the pipeline as well. So that's probably a memory leak. But all right, we're going to fix that at one point. So here, let's go back to our render. So index buffer, we're not going to have it either. So we don't care about it. We set this. So this first one, transform bind group, can go out. Then we have this space with the camera bind group, but that's now position 0. This is at 1, right? The second one, texture bind group. Set vertex buffer, that's all right. We don't have index buffer, we can get rid of this. So in many ways, this class is actually simpler than the only train the pipeline one. I think this might be even fine for the most part, right? Yeah, it is. I believe so. So now finally, I think we're almost there. We can try it. It might work, it might not. Well, let's hope it works. Let's go to our scene. And as usual, I'm just going to copy this cube, this scene. And I'm going to say Skybox test scene. So just in order to not mess anything up. So we can say here Skybox test scene. Everything can remain for the most part the same. So we're just going to need additional images similar to this one. So let's do this left image. You can call it whatever you want, but here, so our left is actually ZX negative, right? If you edit this image, so it should be called, you can use other environment maps or Skybox textures, but just make sure that name is something like left texture X negative, something along those lines. So we're just going to say X negative. So then we're going to have right, which is just X positive. And I'm going to make a bit spacing here so that it's easier for you to see. Top is just Y position, Y negative, right? Then we have Z negative for front, and for the back is Z positive. So we're good there. We have only trained the pipeline, so we can create our Skybox render pipeline. Call it Skybox render pipeline, or just Skybox, whatever you prefer. And then I guess we can load it somewhere over here. So we can say our Skybox render pipeline. So this new cube texture, I'm not happy with it, I'm doing it this way. So I'm just going to create cube texture here, right? Skybox texture. And then, right, when we create it, so just go here, we need to paste left image, right image, top, bottom, front, and back. That's all good. And then we just need to paste that skybox texture right in. Pipeline remains the same, and we need to say skybox initialize. And then we can try to draw it finally. But we don't actually have anything here either. So a moment of truth, probably something went wrong for sure. No way that it didn't, and it did. Okay, this one's easy, because I just forgot to change constructor. Not too bad. Okay, nothing is rendered yet. So I'm definitely missing something. So let me try to fix that. Well, you know what would be a good thing to do? Like, very good thing to actually use our scene. So I didn't even do that. At least this was easy to figure out. I paused the video and immediately figured it out. Like, I should probably do that. So Skybox test scene. So if I do it now, okay, now we're somewhere because we actually got valid error. Group wine binding 0 is not available in the layout pipeline layout. Visibility flags don't include shader stage. So it means it's just something went wrong either in shader. Ah, I know. So it's probably because I never changed the shader, right? If we go to our create pipeline method, I should just use Skybox here. All right, let's try again. All right. Not found, meaning I probably never set this copy to output directory, right? Cannot find it if it's not there. Okay, so now we're moving. Let me see errors here. Text coordinates. So it's probably different type. So I guess this should be easy to fix because this remained vector 2, but it's not. It needs to be vector 3, right? Because we're also now sampling the Z. It's still some errors. Invalid bind group entry for bind group descriptor. Okay. Okay. All right, I found a bug. I think, no, but this is actually correct. My bad, I'm looking at it. I'm not quite sure. It's probably nothing super relevant. Just some small thing. All right. Okay, after debugging a while, I just realized, right, this is null. It means I never actually initialized the cube texture. So just going back to our Skybox test scene. And when we create Skybox texture, we just need to go initialize on it, right? And this should make it fine. So just to make sure, because I'm not sure if I ever set this copy newer, so it's good. Just make sure that your textures are also set, the properties of them are set to copy if new or something similar. So maybe now still some bugs, but that's all right. We're just going to fix them. Okay, validation error given with dimension 2D. Okay, that's clear enough. So we just need to fix it somewhere. We probably bound something. Let's go to our Skybox or our cube texture. It's here. We paste all of this in, but we never created actually cube view, right? So I created a method but never called it. It's there. Okay, so now this might be confusing and it's very easy to figure out what's going on. It just means that we're not at the center of the cube, right? Because we still have our movement here. So let's try to fix that. That's actually really easy to do. So if you just go to our camera, and then we have this one. I'm just going to actually create a new buffer. I'm just going to call it Skybox projection view buffer. I think that's good name as any. So we just need to create it. We're going to create it here. I would leave this implementation to you if you want to play with it, but we're going to implement it for this one. So it's just get private set, and we can just set this. We don't even have to set it here because we created in constructor. So I just realized that this is not necessary. This either probably, then this either. And it's kind of same as this buffer, right? So we can just copy it. Be lazy, copy stuff around, make bugs, and then Skybox perspective camera buffer, direction view camera buffer. And then just below, we just need to update it here. So we already have this view matrix, right? So we can just sort of copy paste this. And what did I call it? Skybox projection view buffer. We make update it. But this view matrix is going to be a bit different. So what we're going to have here is this. So we're just going to create a new view. Right. This is going to be row 1, then row 2, row 3, and here it's already a very good suggestion, because what we're going to do, I'm just going to get rid of translation position. Right? So it's what I mentioned, right? If we imagine our matrix, so right, we have some matrix, and then it usually has some scaling part. Not so true when it comes to view matrix, but and this depends on row or column manager. But what we want to do is just get rid of this, right? So we just want to get rid of translation. Therefore, we'll always at the center of our cube. But why are we at the center? Because our skybox, right? If you imagine skybox, the vertices that I provided, if you take a look at them, they're just some, like, I think it's minus 0.5 or something like that, then minus 0.5, right? And then this top might be 0.5, 0.5, and then same in Z actually. So it's always at the center, right? So that's how that works. Then I need to figure out how to clean this. Good. And then we just need to make use of it. Right, because we need to paste it here. Skybox projection view buffer. So as I mentioned, you can organize data a bit differently if you want to. I'm not doing that. It's still something wrong, but this one is easy to fix, right? It just means probably we have some depth testing and then it fails here, or maybe it's just on the winding order of our vertices. So we can easily fix that if I go to render pipeline util. So our method, which takes vertex buffer layout, right? We use it for cube, so it can be here. So maybe it's clockwise. Probably something like that, right? And we see something here. It's completely wrong though. So it means we probably passed some information wrongly. But let's just get rid of some other stuff as well. So depth testing, where are you? Let's set this to false. Alright, we still have some problems, and I think I know what it is. So we're just going to set calm mode to none. But we can probably return this, right? Almost there. Almost there. I think I did something wrong in shader when loading. Let me quickly check that. Well, I realized my mistake, and my mistake is we actually do not want to transform our texture coordinates. Our texture coordinates same as our vertices, right? So what we want to do is not out. We actually want to do in position, right? Once that we pass here, and this was X, Y, Z, and now it should work, right? Because sort of almost there. It's still complaining about something. Let me just check this quickly. So we have in position X, Y, Z. I think it might be just that somehow my shader is not moved because I tried to make obvious mistake in shader, but it works. So it means for some reason it's not copied over. And I think this is bug on Linux and Rider or Reader. So if I try to set it to this, then it gets properly copied. Okay, so our Skybox work. Obviously, I probably did something wrong with the left or right texture. So these are swept, and this seem like left and right. So I'm just going to flip that around, and I'm going to do it in our Skybox SC. And here, if I just flip this, I think it might work. Not quite, then it's probably front and back. Could be. I'm not quite sure. I just have a feeling right now. Okay. Yeah, I'm going to fix that on hit I'm going to fix that after the video because it's not relevant here. So you can fix it yourself. It's probably something like that. Maybe I just passed something wrongly here. But as you can see, our Skybox works. Works. And the thing is, it's kind of renders like we're always at the center of the screen. We're moving here, but the actual moving part is never applied to Skybox. It just remains there as is, as some small, very small cube actually, and you can see it, right? If you just go to our camera, and if you don't do this, right, you can actually see how it looks. So it's not like you render some huge box all around your screen. You just render small box, and with a bit of trickery you can actually get it to work, right? Because the same happens here if you move to center, right? So if you take a look here, move to center, right, somewhere around the center it works like this. So it works, it's exactly what we did. We just got rid of this part, this translation, and it works like that. Okay, next part that I want to show. So we're almost done here. I just wanted to test this a bit because right now we draw the Skybox first, but what if we render this first, right? Let's try this. Let's say that our Skybox is second. So we cannot see our cube because it's not passing depth test, right? So if you try, you cannot find that cube because it's overwritten, right? Probably by this Skybox. So we can fix that real easy. So if I just go to, let's see. I just want to check this render pipeline util. So we want to have depth writing for start. So now we should be at least able to see it, probably. Still not. Okay, we can see it kind of, right? Depending, right, on where we are. And what's happening is we have some depth testing. But there is a trick on how can you actually fix that. And it's very easy to do. So if you just say W here, I think it should work properly. Almost. So it's complaining about something because our position doesn't quite have that part. Right. So what I want to do is I'm blocked. So that's fine. Oh no, my bad. So our position, right? We want to change that to XY WW. Now, if I try it, almost there. No. Aha. My bad, I'm completely lost here. Now it works and we can see our cube and it works very nice. So I just probably need to explain that part. So let's do it really quickly. So what happens is, it's very simple, right? If you know that we have depth testing, right? So actually I didn't want to do this, but you know in our texture, right? We set depth test to, like in our texture, if value is 1, it's furthest away possible from us, and if it's 0, it's closest away possible from us. And now pay attention to this position, right? If you know, and I think I mentioned this at one point, like this position, right? You have x, y, and z, and this last part actually contains our projection. Why? Because everything, this, right? This and this gets divided, right? After the vertex shader runs, it gets divided by this W, and that's what gives you this kind of perspective and 3D like projection, right? Once you do the matrices multiplication and stuff. But you can actually leverage at it. And if you just place W here, right, instead of Z, what we did here, right, then you just have 1 here, right? W divided by W is 1. And then that means that you're always writing at the end of our buffer, our depth buffer. And that's the trick, right? That's the trick and why it works. So you can always project in the furthest away possible. And the neat part about that is, so I'm just going to explain it. So if you take a look at Skybox testing, right? If you did depth test first, right, and then you would always have to render Skybox first. But with this trick, right, this small trick, you can render Skybox at any position that you want. And the beautiful thing about this is it will perform depth test and it doesn't have to draw the fragments there. So it's a bit more optimized as well. So if you don't want to use that, you can render Skybox first, but you can use this trick and then you don't have to worry about the Skybox position in your scene. Okay, so this was a long video, but I think that's it. We figured out how to do Skybox. I can just recap it real quickly. So the Skybox, we just need our positions, and our positions are actually our texture coordinates as well, right? When it samples them. And the position had to be, what did I use? -1, right? Not 0.5, like I explained, it's actually -1 to 1. But then what we had to do is real simple. We just had to use cube texture, and then we just paste 6 images to it, front, back, up, etc. And that's about it almost. Then in our texture, what's important, I guess in texture util, when you were loading, we had to change this origin Z, right? We had to change that. Everything else almost remained the same. And then we were just writing each individual texture to image to a texture. And then in texture view util, we had to set up dimension cube, and then similar probably in our render pipeline as well. When we were creating this bind group somewhere, we probably had to change something to dimension, to cube dimension. Anyway, you get the idea. Here it is. You get the idea. This video isn't even that hard, I believe. It's just you have to type a lot of stuff. It's like that. The APIs are very verbose. It could have been 5 minutes if we had everything set up. We didn't. But that's it regarding this video. And the next video, I guess it will be a couple of videos, but we might start Actually, let's do physics next time. And for that, I'm going to use library, but once you see it, it's probably going to work really beautifully. And we're going to use that library probably to do terrain physics and stuff like that. So yeah, that's it. If you like the video, maybe like, subscribe, leave a comment, and until next time.